The mooring ropes wrongly wound on the split drums with more than one layer of turns, as against the recommended procedure of one layer of turn only. The mooring ropes have been left sprawling on deck, presenting a tripping hazard. Leads and roller furleads will be checked to ensure they are well greased and are free to turn. The brake testing kit is assembled at the mooring winch on the forecastle. The kit is rigged as per instructions of the kit manufacturer. The objective is to calculate the pressure that will be built up using the
once again expresses its commitment to continuous improvement of its products and services to deliver on the ultimate objective of effective seafarer training. This 23-minute video highlights the various important factors relating to anchoring of vessels. This includes the contributing internal factors of crew experience, the vessel's anchoring equipment, navigational equipments, windage area, UKC, engine power, etc., as also the external factors of seabed, winds, tides and currents. Emphasizes on the procedures for deep water anchoring. Graphically identifies very effectively the various causes for loss of anchors.
The bow anchors are the high holding power, stockless anchors normally seen on board these vessels. The navigational equipment required at time of anchoring, the most influential factors are likely to be current. The head of the anchor is designed to pivot about 30 degrees and 45 degrees on either side of the shank. This assists the anchor to bite into the seabed when the anchor touches the seabed. It is also robust enough to take the heavy loads imposed on it while the vessel is riding to its anchor, and also to the dynamic loads imposed on it by the external forces and by the vessel during anchoring and when swinging at anchorage. It is necessary to clean the anchor when heaved up and also prior re-anchoring if necessary. The nature of the seabed varies largely from place to place. Clay is a very good holding ground, and the holding power is up to 4 times the weight of the anchor. A 5-degree angle between the seabed and the cable, where it connects to the anchor, results in a loss about 25% and the traffic congestion at the anchorage. Windlasses have been known to shear off, or the mechanisms destroyed, due to the vessel being pushed too fast by the current. A suitable anchoring position must be finalized. It should be away from navigational hazards. Decide on an officer to supervise the operation. On bridge, the officer must plot the anchor position and draw a swing circle and the possible drags. The main advantage of letting go of the anchor is that the brake will render before any critical stresses are reached. Larger the area exposed, greater is the effect for constant force. Cable can pile up, leading to poor holding power of the vessel. Must lower the anchor in the water when at or nearly at the anchoring position. Another factor that has greater effect on the vessel during or after anchoring is under-keel clearance. Anchors have been lost from vessels due to any one or more of the following reasons. Loss of anchor due to brake failure. Anchors were let go in deep waters, and the brakes were not capable of holding the cable from slipping. The windlass itself has broken away from its foundation. Anchors have been abandoned due to being dropped in wrong positions, whereby they are fouled in pipelines, cables, and other underwater obstructions. Parts of the anchor such as shanks, flukes, etc. have been fractured. Anchor shackles, especially joining shackles, have failed, resulting in loss of anchor. Anchors lost at sea due to improper securing of the cable, whereby the anchor has slipped off. Loss of anchor due to dropping the anchor, while the vessel had excessive speed. Lastly, anchors were lost during maintenance of the windlass brakes, when the brake liners were being changed.